Hello everyone, hopefully you're doing well. In this video, we're going to uh, continue with chapter one, thinking critically. In the previous video, we went most of all over some basic concepts of thinking critically. For example, we're talking about living in the media age. If you didn't see anything about it, I would strongly advise you to go back and watch the previous video on living in the media age, where we covered a number of common fallacies that you can experience in the media. The fallacies is a deceptive argument in which the conclusion is not well supported by the premises. And we said the premises is an argument used as a set of facts or assumption to support a conclusion. But it's all about logic. That is the study of the methods and principle of reasoning. So whether we do quantitative reasoning, which is reasoning, it's very important. In this section, we're going to focus on propositions. We said that propositions, so having discussed fallacies in the first unit, we now turn our attention to proper arguments. So the building blocks of arguments are called propositions or propositions. That statement that makes statement that make a claim that may be either true or false. Okay, so a proposition must have, a proposition that's a statement that makes a claim either true or false. So it must have the structure of a complete sentence. That's very important, right? A proposition must have the structure of a complete sentence and must make a distinct assertion or denials, right? So if we said Donald Trump, Donald Trump is the first Latino president of the United States of America. This is, at this point, you can consider this one as a statement. That's very important to see that. So the statement can be either true or false, but we said doesn't mean what I said is true, but it's a statement. But if I give an order or ask you a question, get out of here. So that cannot be a proposition. So that's at some point what we're gonna discuss in this one. Any proposition has two possible outcomes. It's either true or false. The true values for a proposition is true or false. T for true, F for false. So a truth that's very important to know. For example, if I said Kyle is sitting in the chair, this is a proposition because it is a complete sentence that make an assertion. Because there is a verb and proposition, and then a complement. So if I said I did not take the computer, it's also a proposition because it's a complete sentence that makes a denial. But if I said, are you going to New York? This cannot be a proposition because it's a question. It does not assert or deny anything. And other examples you can see, if I said, uh, what is 2 plus 13? 2 plus 13 is equal to 7, right? This also is a proposition. So that's a proposition because it's a proposition. Proposition means what you said can be either true or false. But if I said, oh, 5 kilometers from here, that doesn't mean anything. It's not a proposition because it does not make any claim and it's not a complete sentence. Where is the verb in this? So at some point, as we said, you need to verify. So, but it's truth tables after you understand what a proposition is, as I said, it's a claim that may be either true or false. A truth table, a proposition can have two possible true values, either true or false. So a truth table is a table because we must go over, uh, uh, a table. But of course, before that, we will talk about the negations, but let's talk about the truth tables first, because every times we have the true values that can be true or false, or vice versa, we can represent these facts with a simple truth table. So a truth table that has a row for each set of true values. All right. So that's very important. Okay. You can have a one for each values for the considered propositions. All right. Now, if we go for the negations, because it's something else you need to understand about the negation of a proposition P, the logical position of a proposition is called its negation. For example, the negation of Kyle is sitting in the chair that I just gave you, I mean, the negation Kyle is sitting in the chair is Kyle is not sitting in the chair. You see, that's the negation. The negation of 2 plus 13 equals 7 is 2 plus 13 is not equal 7. That would be the negation, right? Is not equal 7. So that would be always you go the other way around. So the negation of proposition P is another proposition that makes the opposite claims of P, right? It is written in different formats. So you see not P, okay? So if P is true, not P means false. If P is false, that not P means so not P is the symbols we use like this. For example, not P, okay? So read this one as not P, okay? There are some other ways people write it. They can write it not P like this. We can say not P. It all depends of the book you use. So if P is true, not P is false. If P is false, not P is true. Another very important, examples. In this case, for examples, you see what we do right there. We try to, go with that negation. That's an example. Try the negation of the proposition Amanda is the fastest runner on the team. Now, what is the negation of this? Right, it's negation. If the negation is false, is Amanda really the fastest runner on the team? You know, in terms of solutions, so the negation of the given proposition is, if you said the negation would be Amanda. What would that be, please? Is not the fastest runner on the team. Is not. That's a negation, right? That's the negation. So we call this one the negations. Amanda is not the fastest winner on the team. So if the negation is false, then the original statement must be true, meaning that Amanda is the fastest runner on the team. So if one is false, the other one is true. If one is true, the other one is false. Let's hope you understand this, but we can also have double negations. Yeah, I know that's my sounds weird in terms of a double negations, right? Double negations mean P, not P is false, then you come back to the same one instead of, in terms of talking about what is good or not, right? Very, very important. So for a double negations, right, rarely involves phrase like not, okay? So we must analyze wording carefully to recognize them. So because that's how you always say not. It's something very simple, but we're gonna go over some examples to see it, very important. All right. Let's see for a few other examples like this. Uh, you know, we would just sit in this situation. What they ask you to do, determine whether the following statements are propositions and give an explanation. We said a sentence or a statement is a proposition if that statement can be true or false. That means it makes sense. But if you if it's an order and a command, go is not. If you just say go, is not a proposition. If you ask a question, it's not a proposition. But let's see this one. Determine whether. So the sky is the limit. Now, if you can think of something that make it either true or false, all right, you would determine if what we said is true or false. Because here, what they said, the sky is the limit, since it is a complete sentence that make a claim, whether it's true or false, immaterially, it's a proposition. So this is a proposition because this one we can say it's true. The sky is really the limit, or the sky is not the limit. Now, the second one said, to be or not to be. Do you think this is a proposition? Well, no claim is made with this statement. There is no claim. So if there is no claim, you would say not a proposition. Not a proposition. No, Back to the Future. Some psycho fans are soporific, right? So if you have a sentence like this, I think I put two at the same time, sorry, because I have two of these here. All right, let me fix it. All right. If we said Back to the Future, do you feel like Back to the Future is a claim that can be true or false? No, no claim is made with this statement. Back to the future. You cannot say it's true or not. It's not a proposition. Every time you feel like you are in a situation where you cannot say something is true or false. So you some psychophants are soporific. Hmm? What do you think about this one? Yeah, this is a complete sentence that makes a claim, you know. So you can say this is true or false. So this one is a proposition. I'm trying to do as much as possible because they said, what were you thinking? Can you answer this one yes or no or not? Well, questions are never proposition. If it's a questions, know that it's not a proposition, not proposition. Okay? Because questions are never propositions. So remember that. Now, 13 times 3 is equal to 20. Is that true or false? 13 times 3? No. 13 times 3 is not equal to 20. But because you can answer by yes or no, it is a proposition. 25 times 4 is 100. Is that true? The fact that you can think of yes or no to it, so it's a proposition. Well, if they ask you what you were thinking, what were you thinking? You cannot say yes, no, right? Back to the future, you cannot say yes, no. To be or not to be, you cannot say yes, no. So anytime you feel you are in a situation that you cannot answer like this, so especially questions and comments, so you cannot consider those as propositions. So I'm hoping you at least have an idea on how those works. Next would be some other exercises we would be doing where we would ask you to write the negation of the given proposition, then state the true value of the original proposition and its negation. So I know we ask you to do a lot from this one. The first thing we can do, I'm gonna just make a space. Okay, you know what? How about I make copies? and put it down here just in case I need it. Okay. Now let's go with one. What they ask you to do here, write the negation of the proposition. Asia is in the northern hemisphere. So what would be the negations of this one? Write the negation. Please verify and tell me negations for this one. Asia is not. Okay, so we can all do already answer this one is not in the northern hemisphere, right? Now, next questions, when we write the negation, then you need to state the true value of the original proposition. So remember, is it true or false? You know, the original proposition is Asia is really located in the northern hemisphere. Yeah, original proposition is true. Okay. Or true. We can say this one is true. That's the original proposition. And this one is false. The negation is false, right? Because that's true. Asia is really located in the northern hemisphere. So if you try, that means the way you can write it, negation, that's false, right? And original one is true. So that's what mostly we want to show you. If we go with the second one, probably, because remember the goal is to do one or two examples and leave you to enjoy what we don't do. If you see Peru is in the northern hemisphere, do you believe Peru is in the northern hemisphere? So what the negation would be? Negation. Peru is not in the northern hemisphere. Now, which one is true? The first one or the second one? The negation is true or the original statement is true? The original statement is false. Peru is not in the northern hemisphere because this is said that here, so that would be false. But this one right here, the negation would be true. You know, it's verified. When I said Donald Trump is the first Latino president of the United States of America, you can be surprised to hear that. But remember, what I said can be true or false. If that statement can be true or false, we call it a proposition. So that's what we want you to remember with those. You know, the same number, for example, here, if we said, you know, the Beatles were not a German band. So what should be the negations of that? Yes, this one is good. I'd like you to verify the Beatles not was not were not a German group. So negation doesn't mean your sentence will be negative. We can say the Beatles. While I'm writing, I'd like you to think where what? Were not or where? Were a German group. Oh my God, I put German like my name, right? German group. Now, which one is true and which one is false? Is the original statement is true or is the negation true? Verify. You know, is Beatles a German group? You can verify that. Yes, the Beatles is really a German group, so this would be true, and this one would be false, right? I mean, sorry, the Beatles were not a German group, so that's true. It was not a German group, so that's true. But the Beatles were a German group, that's false, right? The negative is true, all right? the negation here, because what we need to do to see here, because the original proposition is true, the negation is false. Sorry about this. But we have one more probably we can see. Earth is the center of the universe. So is that something you can verify? If Earth is the center or in the of the universe. So what would be the negation to this, please? Negation. Earth is not the center of the universe. Now, think between the first sentence and the second one, which one can be true? Well, is the Earth the center of the universe? That's false. The original one is false. You can even verify and read. I know you're good with researching social science, geography, and everything. You would figure it out whether the Earth is or is not the center of the universe. Here we know the original Earth is the center of the universe is false. Earth is not the center of the universe. So that should be true, right? So review, remember you have the books that you can do more examples, but at the same time, we can continue doing even more on this. In this exercise, what they ask you to do is to explain the meaning of the given statement, which contains a multiple negations. Remember, we just said about double negations. Then you answer the question that follows. So the questions for this one is what they ask you to do here. Sarah did not decline the offer to go to dinner, right? Yeah, that's English. English, you need to understand. So, okay, Sarah did not decline the offer to go to dinner. It's a double negation, right? Declining already is negations, right? Sarah declined the offer to go to dinner. Did Sarah go? No, he didn't go. But now, if you go, Sarah did not decline the offer to go to dinner. So that's a double negation. Did not and decline is a double negation. So we would conclude yes, Sarah. It's a double negation, right? We can say Sarah did go. But it's a double negation. Didn't decline it. So it went. We're gonna go with the mayor, right? They said the mayor opposes the ban on anti-fracking rallies. Does the mayor approve of allowing the rallies? We're gonna say the mayor oppose, okay? Uh, you know, the mayor oppose the ban. The mayor opposed the ban. There was a ban not to have that anti-fracking rallies. But there was a ban, but the mayor opposed it. So that's again a double negation. It seems like the mayor appears to approve of the rallies. Whether the mayor approves of them is debatable, given the limited information. But it's approve it. Yes, yes, we're gonna go with that because there was a ban not to have the rally. The mayor opposed to the ban, so the mayor approved of allowing the rallies. The president, because the next one would be about the president who, we said the president vetoed the bill to cut taxes, right? Based on this veto, will taxes be lowered? Again, here, um, they were planning on cutting the taxes. There was a bill to cut taxes, but the president vetoed it. Cut the taxes mean lower the taxes, but the president vetoed it. Based on this veto, would you think the VAT taxes would be lowered? No. Taxes, we can say, will not be lowered, right? Yeah, there's a few examples like this, then we're gonna see because we enjoy those type of examples, we can review them all the times. But at the same time, the most important of these are the connectors, because you cannot do anything without the connectors. Propositions are often joined with logical connectors because it's very important to know most of them, words such as, and, or, and if then, for example, consider the following two propositions. P, the test was hard. Okay? Or let's go with that example I read here. P, I won the game. If you have two propositions, it was fun. If you want, you can write one sentence. I won the game. It was fun. We can have two sentences like this. So, and we can connect them. We see I have two sentences that we can connect. I won the game and it was fun. I mean, both, right? You won and it was fun. I won the game or it was fun. Or means maybe both of them, or maybe I only won the game. I'm happy, but it was not fun. Or it was fun, but I won the game also, right? Now, if I won the game, then it was fun. That makes more sense. You can join the two proposition with and, we get a new proposition. The test, uh, it, you know, uh, we can join them with or, as you can see, or we can use the conditions. That's very important to know the connectors, logical connectors. But we have many of them. One of these, you know, uh, uh, you know, connection connectors with logic connectors, we call it the conjunctions. Conjunctions is any times you use and. So an and statement is called a conjunction. According to the rules of logic, the conjunctions P and Q, you can say P and Q are both true. Okay, so we call it a conjunction. For examples, if you have a statement, the test was hard and I got an A. So, it's true only if it was a hard test and you did get an A, right? So, given two proposition P and Q, the statement P and Q is called their conjunction, right? It is true only if P and Q are both true. You see, if I want, let me remove those. You would understand. Unfortunately, I cannot remove it. I don't know why I didn't remove. Okay. So for the conjunction, what we said, if you write P and Q, you can also write it like P and Q, because that symbols right there means and, right? If you see that symbol, that means and. Okay, it's a conjunction. So you see, when both of them must be true in order for the conjunction to be true. If at least one of them is false, then all of them are false. You see, false, make it false, false, make it false, and true, false, false in the conjunctions. That's very important to see. For example, here, when they ask us to write those P, Q, and R, because we said make a truth table for the given statement, the letter P, Q, R, and S represented. So you know what? I'm gonna go with the fastest one in this case. because if you go with one, if we have a table where the first proposition is Q, oops, sorry, if the first proposition is Q and the second proposition is R, and you're gonna have Q and R, but I'm gonna use that symbol for Q and R. Remember that symbols here, that's mean and. I'm going to use these symbols, all right? Now, the first thing to verify, when you have a statement, the statement can be either true. If you have two statements, the first thing we about two statements, both of them can be true. Or the first statement is true, but the second statement is false. Or the first statement is false, but the second statement is true. Or both of them are false. So it's either both of your statements are true, or both of them are false, or one is false and the other one is true. So you see I have only two statements, two propositions here. Sorry, I only have two propositions. So I have four possible outcomes, either both true or both false, or the first one true and the second one false, or the first one false, the second one true. All right. Now let's see for the conjunction. Remember this one right here is Q and R. Okay. Two true, I mean, in order for a conjunction to be true, both of them must be true. So what letter I should use for the first one? Yes, both of them true, then it's true. How about the other ones? Yes, the second one false, then it's false. The first one is false, then it's false. Both of them false, then it's false. Now you understand how that's work. We can go with number two, because number two, we have the Q and S, and you have P and S. I'm trying to write it both ways. Either I write it like the symbols, or we can just end in the middle. So now let's see it. We said if P is true, that may happen. The second proposition is true also. Or the first proposition true, the second one is false, or the first one is false, the second one is true, or both of them are false. So that's how you go first with your propositions. Once you get your proposition, now you verify again. The first two is true, then the conjunctions is true. Otherwise, they are all false because at least one of the other two are false, right? Is false. So you cannot, you can continue that way to make sure that it's truth table for the conjunction P and S, okay, we analyze all possible combinations of the truth tables of the individual propositions, right? Based on P and S, each have two possible truth values, true or false, okay? So I think now that the end statement is true, right, you can say that both of them is true for the first one. At the same time, for the other ones, they would be false. All right. We can do another examples very quick because it's important to do as many as possible. Let's go with the end statement, and because we are still in the end statement. We said that the following statements have the form P and Q, okay? And P and Q. State P and Q and give the truth tables. Then determine whether the conjunctions, the end statement is true or false and explain why. All right. So for these ones also, what we can do is go by one by one. So what is P here? Okay, this is the conjunction. So what is the conjunctions here? Right there. So we can consider the first statement here, dogs are animals. Dogs are animals. Let's call this one P. Oak trees are plants. Let's consider this one Q. So you have two statements, P and Q, right? Because I have two statements P and Q, dogs are animals. Do you believe dogs are animals, right? Dog for proposition P. Dogs are animal. Q, oak trees are plant. Okay, now tell me, is the first one true? Do you believe this statement is true? The first one. Yes, dogs are really animals. That's true. And do you also believe oak trees, they are plants? Yes, they are true. So at this point, you can conclude that since the conjunctions, both propositions are true, the conjunction is also true. So conjunctions true, right? Because both of them true. Now look at the second one. If we try to do the same thing, do you believe 6 plus 12 is 18? I'm gonna call this one P, right? And 3 times 5 is our second proposition, that's Q, right? Do you believe, because we have P is 12 plus 6 is equal 18, that's true. And Q, that is 3 times 5 is 8. Is it true? No, false. So what would be the conjunction for these two? Yes, conjunction is false because the conjunction is false because both propositions and conjunction must be true for the entire statement to be true. If at least one of them is false, then it's all false. You know, all of them must be true in order to consider it that way. If we go with Venn diagram, maybe let's try it. For this one, we said that Venus a planet. And the sun, let me go with a different color, maybe. I'm gonna go with red. Okay, Venus, a planet. I'm gonna say this is P. And the sun is a star, right? And the sun is a star. I'm gonna say it Q. So look, if we have P, I'm trying to write it different ways. If we said, what is P and Q in this case? If we said P, is Venus a planet? So you need to verify that. Do you believe Venus is a planet, right? Well, it's true. Do you believe the sun is a star? Is the sun is a star? Yes, the sun is a star. So since both propositions are true, so the conjunctions is also true. All right. And I'm gonna let's write that. Not all men are tall. So let's call this one P. And not all women are short. We're gonna say not P and not Q because it's a not. All right. For us, P, all men are tall. Q, all women are short. Okay, so I'm gonna say not. So if you construct a small table with not P and not Q, or you say not P and not Q like this, not all men, not all men, uh, you know, um, at all. Do you believe that that is true? Not all men at all, right? That means some of them are short, so that's true, right? And not all women are short. Do you believe that? Yes, that's true. That not all women are short. So two true, because in this case you see both propositions are true, we would conclude the conjunction is also true. So we have a few examples like this that you can verify. When you have three of them, when they ask you to make a truth table, so you know what happened. I'm gonna do probably the first one when you have Q, R, S. Now they ask us to make sure we do Q and R and S. Remember when we put that symbol, that means and, right? Now, okay. First of all, you always need to construct. If you want to know the number of statements you can have from here, truth values you can have, is 2 power n. N is the number of propositions you have. So n is 3 here, so we're going to have 2 power 3 is 8. So we're going to have 8 of them. What we mean by that, when it may happen all your 3 propositions are true. Or maybe the first proposition is true, the second proposition is true, but the last one is false. Or maybe only the first one is, or the first one is true, the second one is false, and the last one is true. Or maybe only the first one is true and the other two are false. Right? Now you see, you use all the truth values for the first proposition. But how about it may happen the first one is true, but the other three, the first one is false, the other two are true. Or the first one is false, the second one is false, but the last one is true. Or maybe the first one is false, the second one is true, and the last one is false. Or all three are false. So if you count the number of true values you have here, 1, 2, 3, 4, 5, 6, 7, 8. So more propositions you have, the longer would be the line. Now remember, for and, when we do and, both of them must be true. Okay? So what would you put for the first one, please? Yes, please, you need to verify and let me know what would you do for the first one. Yes, the first one is true because all of them are true. How about the other ones? Because at least one is false, every other ones would be false because in order to be true, all of them must be true. That's what we call and. And is when you have it that way. So, of course, we can go over and do I do only, remember, I do only PQR here. In the previous examples here, I do only Q and R or P and S. But it may happen they ask you to do for 4 of them. Like you need to do P, Q, R, S. You know what's gonna happen? What is N here? Yeah, N is 4. That means 2 power N. It's 2 power 4. So that will be 16 true values in your table. So good luck with that one. I'm hoping you can do it. And probably I would ask you to do it through a project or something. But right now, let's consider you got it. All right. So what we're gonna do in the next examples, probably, we're gonna cover a few other examples with, you know, with or in this case, it would be better that I register this part in a second video. So let me know if you have any questions. I'll come back to continue with not the because we already do the conjunction, but in this case, we would only do the disjunctions because it implies or statements. I'll see you in a different video for this one. Take care.